Bismillahirrahmanirrahim. Assalamu alaikum. Today we are studying topic number 9.9 and 9.10, Fraunhofer diffraction at a single slit. Okay. So first we are define Fraunhofer diffraction. Fraunhofer diffraction says that the plane of incident light and diffracted light will be same. It means that diffraction cannot change the plane of waves. Diffraction cannot change the plane of waves. So whenever the wave come in xy plane, so it will be diffracted in the same plane, that is xy plane. When the wave comes in yz plane, so when it is diffracted, so the plane will remain the same. So it means that the plane of wave will not be changing during diffraction. Okay. So this experiment is performed. Look at the construction. This is the primary source which producing light, and this is a slit. I'm going to shade it. This is another slit. Okay, so I'm going to shade it. So here there is secondary source A, B, C, D and E. There are 5 secondary sources are produced. A, B, C, D, E. A, B, C, D and E. There are 5 secondary sources are produced. Okay, this is the screen. To focus the light on the screen, we can use the convex lens, but it is not necessary. So the light from the secondary source A will be bent in each and every direction. The light will come from point B secondary source will in each and every direction. So the light come from point C will be in each and every direction. So the light will come from the secondary source in each and every direction. But I am going to study the bending of light in a one direction. Suppose this is A, this is B, this is the bending of light through C, the bending of light through point D, this is the bending of light through point E. Okay. So I studied that the light is bending up. In our book, the light is bending down, but I am going to study when the light is bending up. The light is bending in each and every direction. So to understand this topic, we should study a single direction. So this wave is called A, F, G, H, I and J. So the first wave is AF. The last wave is EJ. So if someone asks you, is the path of AF and EJ are equal? So the answer is no. Look at here, EJ cover more distance and AF cover small distance. So it means that they have some path difference. So draw a perpendicular line on EJ. So whenever we draw a perpendicular line, that is called K. So look at here. If someone asks you AF and KJ are equal, so the answer is yes. AF and KJ both are equal, both have the same distance covered, so both have the same path. So KJ and AF are equal. It means that the path difference between AF and EJ is EK. So this is AF, this is EJ. So the path difference between them is AK, EK, EK. So if there is no EK, so it means that both will be equal. So it means that EK is the path difference between AF and EJ. So this is called S. Okay. Now this is line from A to E. So the distance between A to E is called small d, means the slit width. What is D? D is called the slit width. Remember, D is called the slit width or slit spacing or grating element. Okay, this is called angle of diffraction theta. This is the angle of diffraction theta. Okay, and we know that sine theta is equal to perpendicular divided by hypotenuse. So perpendicular side is EK and the hypotenuse is AE here. So EK will be equal to, from this equation, EK will be equal to AE sine theta. And what is EK? EK is the path difference S. And what is AE? AE is the slit width, which is called small d. And suppose there is a constructor interference occur in AB and EJ. AB and EJ constructor interference will occur. So what will be the path difference for constructive? So that will be equal to m lambda. So this is the condition, this is equation is used for the constructive interference in single slit. So look at here, this m is a whole number, this is the wavelength of light, this is the slit width, this is the angle of diffraction. So it means that we can find the wavelength of light by this Fraunhofer diffraction. So by diffraction we can find the wavelength of light. Okay, so Fraunhofer just only said that the plane of incident and the plane of diffracted wave will be same, and by this equation we can find out the slit width by this equation. By this equation we can find the wavelength of light. So this is about this topic. If you have any question, then you can ask in comment section. But remember one thing more. You know that in diffraction pattern the middle spot will be more brighter, then the second brighter will be a bit smaller than the central bright, then the third bright will be more smaller than the second bright, and the fourth brighter will be more smaller than third bright. So it means that the bright spot will be get decreasing. The bright spot will be get decreasing by increasing the distance, while the dark spot, there will be no dark spot at the middle. There will be a small dark spot, first dark spot. There will be a bit larger dark spot from the second. There will be a third big large dark as compared to the second. So it means that in the diffraction pattern the width of the dark and the width of the bright changes throughout the pattern. So it means that at the middle the brighter spot is greater, but there is no dark spot. But if we going beyond the middle, so it means that the dark spot increasing and the bright spot is decreasing. Okay, if you have any question, then you can ask in comment section. Okay, take care. Allah Hafiz.